Hi everybody, this is Kira here from EPS. I'm just going to wait another minute or two while we have more of our attendees join us, and then we'll kick off. Okay, I'd like to welcome everybody this morning to the next episode in our It's Open Networking webinar series. So today we're focusing on an exploration of data center network automation with Apstra. My name is Kira McCarthy and I'm the Global Marketing Director for EPS Global. So just to give you a bit of background on EPS, we're the open networking distributor of choice globally for a whole host of industries. So we sit at the center of the open networking ecosystem. So we bring together the hardware and the open networking operating software to create turnkey solutions for our customers. We offer technical advice, configuration of software and hardware bundles, that's switches, optics, cables, and more. So we've been around for 20 years. This is our 21st year, and we have 28 locations around the world. So we're never far away. I would like to introduce our speakers today. First of all, we will have Barry McGinley. So Barry is our systems engineer for EMEA. So he's one of EPS's resident techies, and he has a deep knowledge of open networking. He primarily works on proof of concepts for data center deployments and the new bare metal hardware for carrier and telecom solutions that's available, from the Cord platform within the ONF to some backhaul projects within the telecom infra project. Barry is based in Dublin, Ireland, enjoys a pint of Guinness, and is an avid Celtic supporter. I'll let him speak for himself later, but he writes an excellent monthly blog that's worth checking out on our website at epsglobal.com. It's a popular tech blog, excuse me. I'd also like to welcome Mehdi Abdelwahab from Apstra. So he is a solution architect with Apstra. He has 15 years experience in the industry with both service provider and hardware vendors. With an in-depth expertise in data center and wide area networks, his focus has been on network automation for the past 4 years. Mehdi joined Apstra 2.5 years ago as the first SE in EMEA, and he is involved in both end customer engagements and channel technical enablement. Mehdi is based in Paris, France, and we're delighted to have him with us here today. So just a bit of housekeeping. If you have any questions, just type them into the Q&A window at the bottom of Zoom, and Barry or Mehdi will answer those questions at the end. And if there's anything that we don't get to, we'll respond to you personally after the webinar. So with that, I would like to hand over to Barry to get started. Thank you.
Thanks, Kira. Good morning, everybody, and thanks for joining us. So what we're going to have a look at today is I'm going to give an introduction to EPS, so kind of explain exactly what we do in open networking. I have a high-level overview of open networking hardware and software, and some of the kind of organizations, I suppose you call them, foundations that kind of help the ecosystem. Then Mehdi's going to have a look at an intro to Apstra, explain what intent-based networking is, and then with AOS, have a look at the actual design phase, validation phase, and some troubleshooting and analytics. And as Kira said, any questions, we'll cover them at the end, and we'll have a quick summation. Okay, so EPS. So we're 21 years old this year, and for the last 7 years, we've been involved in open networking. That came about because we became global distributors for EdgeCore networks. For anyone who doesn't know EdgeCore, they're a subsidiary of the Acton Group, who are an OEM, ODM out of Taiwan. And if you've used a switch that's not Cisco, you've probably used an Acton Group switch. So what Acton did was they spun out a company called EdgeCore to look after all the bare metal. So Acton themselves look after the branded boxes, I suppose you could call them, are bright boxes. So that's HP and Dell and that kind of thing. So yeah, about 7 years ago, so early enough in open networking, like 2013. And I think we kind of realized fairly early on that the normal rules of distribution didn't apply in open networking because it was quite new. So we had to get out and start evangelizing about open networking and explain to people what it was. And then as well, the hardware is only one piece of the puzzle. So we went out and started talking to the NOS vendors, and we always say not just some of the NOS vendors, all the NOS vendors. It was very important for us that we don't kind of pigeonhole a customer into a particular piece of software just because it suits us or we have a better relationship with one of the vendors. There's enough software vendors out there to find the perfect fit for each use case. So that's important to us, and that's a service we provide. Other services we provide, so for those NOS vendors, we can do kind of branding, that kind of stuff. But as well, we can put the operating system on, the licenses on, and obviously ship with interoperable transceivers and cables. So we try and take a little of the hardship out of open networking because it can be a bit daunting. Customers, right, grand, we have bare metal, so we've multiple vendors for this. Then we've got multiple network operating systems. Then hardware compatibility lists for transceivers, for DACs, all this kind of stuff can get a bit confusing. So we take that hardship out of it for our customers. And basically we can have switches ready to slide into a rack for our customers and for our NOS vendors, our partners as well. So that's briefly what we do. So I'm going to give a kind of high level overview of open networking before we go on to Maddie. So the first one we look at ONF, the Open Networking Foundation, founded in 2012, primarily to do what we did as well, kind of push the benefits of SDN, and they looked after the OpenFlow protocol as well. So OpenFlow was the first protocol that allowed for the separation of the control and data planes. In 2016, they kind of changed course and started a project for the carrier market. So it's cored, it's central office re-architected as a data center. So this is to put bare metal and bring what's happened to the data center into the central office for carriers and telcos. So that was 2016, and by 2019 they had reference designs for a bunch of projects. So SEBA, which is software-enabled broadband access for residential and enterprise broadband, COMAC, Trellis, which is spine and leaf in the central office, ODTN, which is optical transport. And then by 2020, late 2019, 2020, they started kind of rollout. So Turk Telecom are running with SEBA, that's the software-enabled broadband access. Comcast are running Trellis in their production network, and there's a bunch more. So worth having a look at if you haven't seen anything on that. 2012 then as well, a couple of months after the ONF, the OCP were founded. And the reason behind this was Facebook and Intel. So Facebook redesigned all their hardware, but it was kind of to start a bit of a revolution and collaboration in hardware that we had seen with the Linux community and software. It's been a big success. And kind of briefly the way it works, if you're a member, you can give in a specification. So we'll say EPS, say we're looking for a 100 gig switch with 32 ports and 6 400 gig uplinks, something like that. Then anyone else who's a member can give in design files based on those specifications. The OCP accept the design files, and then companies can go off and build the actual hardware based on those design files. Once the hardware is built, the OCP accepted as an OCP accepted product. It goes into their OCP marketplace, and then the design files of the actual build are shared with the entire community. So that's this kind of cooperative, collaborative affair. And as well, so all the hardware that's used, well, just about in the ONF's projects and TIP, which I'm going to talk about now, were born in the OCP. So you can see how this is kind of a community. So the final one there is the Telecom Infra project that was founded in 2016, around the same time the core platform started with the ONF. So obviously it's for telcos. And there's 3 project groups. We have access, which is your RAN access, backhaul from the towers back to their data center, and then core and services, which is there's projects on segmentation and end-to-end slicing and things like that. They have a bunch of their products on the TIP exchange. It's worth having a look at as well, if you have the time. Okay, so briefly on bare metal hardware. most people will know most of the vendors here: EdgeCore, Quanta, Celestica, Mellanox, Delta. And just to give you an idea of scale, and this is 2018 now, that's the figures. EdgeCore shipped 20% of the global data center switches. So a big market, and they have a big share of it. Okay, so on to software. I'm going to split the software into two areas. So we have commercial software and we have open source software. And then I've split the commercial into data center, communication service provider, enterprise, and intent-based. I could split them all again multiple times because, as I said, every use case is kind of catered for. So when we look at data center, we have Cumulus Linux from Cumulus, Picos from Pico 8, Ognos from IPN Fusion. Pluribus have a range of products. Of NetVisor one is it would be their data center operating system, but they have an adaptive cloud fabric, an adaptive monitoring fabric now as well. But we could split the data center again into two different sections. So we could say individually managed devices to centrally managed devices. So say Cumulus, Pika, IPN Fusion, you still manage you can automate with DevOps tools like Ansible, Chef, and Puppet, but you're still dealing with individual devices. Whereas so we have Big Switch, we have Pluribus. So Big Switch use a controller. Pluribus create a fabric a different way, but they manage the entire network rather than an individual switch. We've got our communication service providers. It seems like there's a new one of these every couple of weeks. And it's not because they're brand new. It's more than likely because they've been in a kind of secret proof of concept with a tier one telco for a couple of years. So RT Brick have been working with Deutsche Telekom for a good few years now. We've DriveNets, Ognos from IPN Fusion. They have a bunch of really good products like cell site gateway for 5G networks. They have a white box transponder now, which is part of the one of the big TIP projects, the Telecom Infra projects. That's a mouthful. Arcus Radisys works on the SIBA pod with the ONF, and Volta Networks sits on the cell site gateway, so it's router software. But there's a bunch more. There's an awful lot more. There's Exaware, and as I said, there's new ones kind of popping up all the time. On the enterprise side of things, we have Pico 8, Enterprise Data Center, Pluribus as well with their NetVisor 1, and Cumulus. But Cumulus have another play here as well. So I suppose the last area that open networking hasn't really penetrated is kind of campus networks. And Cumulus weren't really looking at getting into that, but I think they have maybe 30-something% of the Fortune 50 companies. And it was those guys that came to them and said, here, you do our data centers, can you do our campus networks as well? So it took a lot of work. They had to add a bunch of features that they didn't have, like port security, multi-gigabit, things like that. But they went off and did it. But now companies are seeing the benefit that, right, their DC is done with Cumulus, but now their campus is, and they can use the same tools that they were using in their data center throughout their entire network. So that's kind of a space to watch for open networking. Then we've got intent-based networking, which is a completely different way of doing things, very different to how Cumulus would do things. And we're going to explain that, or Mehdi's going to explain that properly in a couple of minutes. And then finally, just the open source software. So we've got ONL, Open Networking Linux, which is run by the OCP, which is kind of a foundation level operating system. So you can build your feature set on top of it. So Big Switch uses ONL as its base. We've OpenSwitch from the Linux Foundation, which is dying a bit of a death, and I'll tell you why now in a minute. I think that was Dell's originally. We've Onus and Stratum from the ONF, which is, I was mentioning the ONF Chord projects, or it's a platform, and then the projects that run inside that, they all use Stratum as the NOS and Onus as the controller. And then we've Danos from the Linux Foundation, so AT&T also use that. And then we've Sonic. So Sonic is kind of the important one I wanted to get to. So Sonic software for open networking in the cloud is running Microsoft Azure's network operating system. So I think they gifted that to the OCP in 2016. And that was fine at the time because Microsoft built it with the feature set that they required for for their data centers. But as more and more people use it, so it's containerized. So every time someone else does a new deployment, they add more features. And basically the feature set is getting to a point, a kind of critical mass point. So now we have Alibaba, Tencent, I think eBay, and there's a lot of large enterprises like Target in America and another bunch looking at it as well. And it's kind of, so all it's in the repository in GitHub, and we've kind of reached a point where, or we're close to reaching a point where just about every use case is going to be covered soon enough. And you know, it's to be taken seriously when you see the hardware vendors that are involved. So Dell, Mellanox, EdgeCore have a huge amount of commits. So it's definitely watch this space. And I think Mehdi's going to mention some about Sonic now. So thanks for your time, for listening to me for 10 minutes, and I'll hand you over to Mehdi.
All right, thank you, Barry.
Yes.
So I'm gonna share my screen. All right. So, right. So thanks for the opportunity to present. So, so I'm from Apstra. So I'm gonna give you an overview of who we are and what we do. So, so we are. So you heard Barry, saying that EPS is 20 years old company. So we are younger than that. We are a software startup. Created in 2014, and we are focused on the domain of what we call intent-based networking. So, so this is to give a very high level of kind of our mission on Earth and what we are going after. So we are laser focused on giving you the ability to drastically simplify the data center operations, actually the data center networking operations. So that's our mission. So the goal is to provide a network automation solution. We use the term of network automation and not terms like SDN and so on, which have been the first generation of automation intent, and now the network automation is becoming the de facto approach for this type of domain. So we are a network automation solution that gives a turnkey automation suite for the data center operations for the enterprise market and the service provider market. So the goal is to give you something that drastically simplify those operations. We use the term operations because it spans from the design up until the deployment and the validations of that infrastructure. So it's the entire lifecycle operations that are under the scope of the management here. So that's the first important pillar. The second one is that we are a software company. We do not provide any hardware switches nor any network operating system. We only manage those. So we are agnostic to the different hardware/NOS combination in that space. We support all the big players in that domain, so which is the data center domain. And the goal is to be, as I said, vendor agnostic for the purpose of giving you option and choice to select and pick your favorite vendor. The goal is to completely decouple your requirement from the choice of the switch vendor, as well as to give you the ability to change and to introduce like new vendors. We hear about Sonic and the ability for you to as well introduce those new network operating systems and benefit from the innovation there without having to reskill all your teams and having a huge impact on your operations. Actually, we are able to do that with a very, very, very minimal impact. So that's a very important aspect for us. And of course, we are a startup that is laser focused on the technical innovation. We are privately funded, so we have the ability to execute on our roadmap, and we have very clear vision on where we want to go, as well as address other domains in the future to expand beyond the data center scope. So our claim is intent-based networking. I'm sure you have heard of this term before. So this appears as a management layer that sits in between you and the infrastructure. So you interact with this infrastructure, with this this management layer, which is the AOS server, and you express your desired outcome. So the goal is really to focus on what you want instead of how you want to implement it, which is an important paradigm shift for a network engineer, where we have been used for years to be prescriptive in our configurations and CLI configurations and with all the details that goes with it. So we believe in the need to start from the desired outcome as a prerequisite to achieve this web scale agility, right? So you have to define your high-level goal, your high-level requirement, and let a sophisticated abstraction engine like AOS, where we have modeled the reference design of our data center domain. You have to let that piece of software then generate the exact configuration as well as all the validation that result from your high-level specification. So this is the way to achieve really, the agility you're looking for, both in terms of, standing up infrastructure from day one, as well as all the day two operations that you perform on this infrastructure from a configuration standpoint, and as well as any monitoring and validation you want to achieve on that. So we really view, the infrastructure as a system instead of collection of boxes. You express the desire to provision an infrastructure, to provision a network service, and instead of requesting a specific switch configuration, right? So the goal is really to focus on the what. We take this high-level requirement and we enforce it as well as we validate it in a closed-loop manner. We are, positioned for the data center leaf spine. That's what we do today. We do that from the perspective of open standards in terms of network design. So we talk about IP fabrics with BGP control plane. We talk about things like EVPN VXLAN, which is the de facto standard today for network virtualization. All of that based on the standard IETF, RFCs, and the de facto standard for modern leaf spine architecture. We consume only the standard features from the switches. There is nothing like proprietary that Apstra is adding on a given switch. If we support a leaf spine on a given vendor, it's only the known and supported features of that vendor that are implemented, and that this is done via API calls instead of CLI configuration, but it's only basically focused on the standard feature set of that vendor. Now, what do we mean by intent? So this is really spanning from the physical specification, your topology in terms of rack design, in terms of leaf spine design, like things like your contention ratio between the servers and the leaf, between the leaf and the spine, up until the super spines. So all the physical topology attributes, as well as all the logical ones, like what network policies you want to enforce there, what tenants you want to provision on this infrastructure, what services on which tenants you want to have, what security policy you want to enforce there, and all of that expressed in a very high level, agnostic way, which is always the same regardless of the vendor that you select. So it's really that notion of abstracting the underlying devices to give you the very same experience, which is very abstracted and logical. So these are just really high-level examples of the intent specification. So then the solution, as I said, spans the entire life cycle. We believe in the need, of course, to start from the design, from a blank sheet of paper, where you do a logical design of your entire entire topology, as well as then your network service specification. You then deploy this this topology. It becomes a running system, and then we focus a lot on the validation phase, because we know that network engineers spend much more time validating a given service than configuring it, right? You spend more time typing show commands than changing a configuration. So as such, this task, which is an operational task, deserves to be automated even more than the initial configuration build, right? And then as you go along, any small change you apply on this running system, makes the validation even more complicated. So it is really critical to be able to automate that step, and not just basically limit yourself to automating the initial configurations, right? So very quickly, like just to give a high level, I mean, when we talk about the design, so you start, as I said, from a blank sheet of paper, and you compose your design by using kind of a Lego of logical building blocks. So we have notions of logical devices, which is very, very generic. And then you create rack types, which basically, define how you want to design your different racks. And then you compose a higher level topology, which we call templates, which are composed of different rack types. So this is really your network architect hat, and kind of replacing your Visio diagram architecture, right? From there, you can then apply this topology on various vendors that we support. So you see here, the usual suspects of the data center space. So established players or traditional players, I would say, like Cisco, Arista, and so on, as well as all the open networking approach with so Cumulus, which have been supporting historically on various platforms, as well as now Sonic. So a word on Sonic. So we have been supporting it from late 2018, early 2019. There has been these last months a huge improvement on Sonic, and a huge amount of work driven mainly by Broadcom and some other players, where we now see, in addition to the open community edition of Sonic, the one that is available on GitHub, we now see an enterprise edition of Sonic, mainly driven by Broadcom, which has all the enterprise grade requirement, and that is feature-wise as well as management, from a management perspective. So feature-wise, we now have things like EVPN VXLAN, which is now available on Sonic. It was not the case until now in the community edition. So that's an absolute must for the enterprise market. When I say enterprise, that includes as well, service providers that also needs EVPN VXLAN, as well as things like MLAG and all the management framework that is also enhanced. So this Broadcom Enterprise Edition is now supported on Edge Core and other ODMs. We support iOS, that Enterprise Edition. So we have already, several ongoing, POCs based on iOS/Sonic/Edge Core, and we really believe, like 2020 will be probably the year one for Sonic, outside of the big elephants like Alibaba, Tencent, and so on. So and it aligns very well with our goals to give option to customers and reduce cost and so on. So it's very much aligned with our vision. So the goal is really to have a design that you can apply on different vendors, completely decoupled between the two, and again, the ability to start with one given platform and swap to another one from the hardware or the software perspective. Then once this is deployed, you have the ability to consume this by expressing the intent for these services. So the main one being provisioning, virtual networks, which is, extending VLANs between different racks. And this is just a screen capture to show how easy that can be, and despite the complexity, the underlying complexity of this configuration. So this is where you select like a bunch of racks and the need to provision a stretch VLAN between different servers in those racks, and you do that, graphically here or in tabular way. But really is really to show you how declarative that is in terms of specification and how abstracted that is, despite, as I said, the quite complex EVPN VXLAN configuration that goes under the hood, and there's a BGP configuration component to it, which is quite complex as well. And this is totally abstracted. It's very service oriented, and then the goal for us is not only to simplify the time it takes to provision it, but also to shorten and automate the validation of that even specific service, right? So so we have this idea where we want you to be able to provision services in minutes, and right after that start to have the service assurance component of that service. As you can see here on the right, like the validation of that service on a physical topology. So we have a bunch of videos on YouTube that we keep adding, regularly. So this one is one that I like, 5-stage under 5 minutes. We have one of our colleagues from Text Report showing that how to build, 5-stage, as we know, is quite a complex topology in few minutes, right? So now, talking about this validation, which is crucial, right? We have this contextual analytics that looks at the entire state of your network in the context of your intent, and then raise any anomaly if a given network service or any state is deviating from the expectation. So this is really giving you this ability to have a closed loop monitoring in an effortless way, right? Where you really can focus your attention on the health of your system in the context of the intent that you gave to iOS, right? So it comes down to things like reducing alert fatigue, right? And avoiding having people staring at screens and analyzing like a long list of anomalies. We automate that steps of filtering out and really focusing your attention on the actual health based on what you want the system to achieve. So few other screen captures, we validate the topology here, like the cabin topology, and then higher layer validations, like traffic counters here that are seen in different ways, like time series database, as well as more real-time traffic counters. Monitoring, all of that is contextual. As you change your topology or your service, this is updated in real time. You don't have to update your monitoring stack as you change your intent. And then, moving on and going deeper in the details of the validation and why that can be a challenge is when you look at open networking, right? And as I said, EVPN VXLAN is the de facto standard today, right? It is open and it's supported on various platforms, and it's standard and interoperable and so on. But it comes at the drawbacks of a very big complexity that is manifesting, particularly in the troubleshooting phase, right? So, for example, this is a show command running on a Cumulus switch, right? So you get the same output on edge core or different platforms, and it shows like. It's just like a simple show command of a particular EVPN route type on a given switch, right? And the output is quite complex because we're talking about a multi-protocol BGP. So the point being, I'm not going into the details here, but the point being is to interpret this result. It's quite complex, and what we are doing in iOS is we have this ability to generate the expectation in real time at scale anytime you change your intent. So iOS is able to, it's almost like having a CCIE or an SRE in a box that type in this show commands all the time on all the switches, and is able to know right away if something is missing or something is wrong, like immediately, regardless of having one or 1,000 of virtual networks, right? So we have taken all the standard EVPN VXLAN, RFCs and specifications, and we have codified those. We have codified the behaviors, like the EVPN behaviors, in analytics dashboards, and those will really be kind of your SRE. That of course is able to reason at scale without the human factor error, and that is something you cannot get rid of if you want to achieve web scale agility it's absolutely important to be able to validate the scale, because otherwise any automation you have is not going to be extremely efficient if you're not able to validate it at some point in time. So we have a very, very strong focus on as I said, codifying the behavior of all those complex protocols in analytics pipelines. We call them probes, to really have this automatic validations, right? And as you can see, you have a service-oriented view where you can see the name of your VLANs and VXLANs and the state, the corresponding state of those services, to really give you a very accurate information on how that service is behaving beyond just like the switch. It's really a service view on a given system scale. So that's what I have today. So we can open it now for questions. So I guess back to you now, Barry.
Thanks, Mehdi. That was excellent. Don't think we have any questions there. See, no, not at the minute. Okay, so we'll finish up. I think I have a few more slides. One sec, I'll share my screen. Okay, so we have a few more webinars coming up. Next one up is Pluribus, automating distributed data centers with controllerless SDN. We've Pika 8 looking at campus networks. Some of my blogs there. Yeah, that's about it. If there's no questions, we can leave it at that. So thanks everybody for joining us this morning. Thanks for your time. And this will be sent out to you again anyway. The slides and the video and any information you need, either contact myself or Mehdi. Thanks very much for your time. Cheers, Mehdi.
Thank you. Thanks, Barry.
Thanks, Mehdi. Thank you. Bye.
Bye.